and welcome back. Now these secondary refrigerants can be used as different mixtures, that is mixture of water and sodium chloride, or mixture of water and calcium chloride, or ethyl glycol, or propylene glycol, or glycerin. So depending upon the application, we can use the different combinations as a secondary refrigerants. Nowadays, mainly used second refrigerant is brine solution and air. Air is also used as a secondary refrigerants. Now, the primary refrigerants are again classified into number of groups. So first is halocarbon compound refrigerants. So these refrigerants are sold in the market under the trade name that is Freon, which is famous, that is Freon. In a market, these refrigerants are sold, or these refrigerants are introduced in market with the help of the Freon name. So this group includes refrigerants which contain one or more of three halogens, that is chlorine, fluorine and bromine. So due to the presence of these halogens, these refrigerants are called as what? Halocarbon compounds. So these refrigerants are derived from methane and ethane. So the presence of the fluorine in the compound make them non-toxic. So due to the presence of fluorine, these compounds are non-toxic compounds. But due to the presence of chlorine, these are ozone unfriendly because the chlorine is responsible for the depletion of ozone layer. Due to this drawback of these refrigerants, that is depletion of ozone layer, nowadays the use of these refrigerants should be totally stopped. For example of these refrigerants R11, R12, R13, R21, R22. So all these are the halocarbon compounds. Second is azeotropic refrigerants. Now these azeotropic refrigerants means what? So these refrigerants are derived or formed by mixing the different types of refrigerants or compounds together. And a group of refrigerant whose code starts with a digit 5 or letter 5. All these refrigerants are called as what? Azeotropic refrigerants. In these refrigerant, the mixture of different refrigerants that cannot be separated into their compound with change in pressure and temperature. They have the fixed thermodynamic properties. These refrigerants have fixed thermodynamic properties. For example, of this refrigerant is capital R500 is the mixture of R12 and R152. Similarly, R502 is a mixture of R22 and R115. R503 is a mixture of R23 and R13. R504 is a mixture of R32 and R115. So these azeotropic group of refrigerants, we can use these refrigerants in a different applications by adding the different refrigerants having the desirable properties. If we add two different refrigerants having desirable thermodynamic properties with each other by eliminating the drawbacks of these refrigerants, so we can form different compounds like these isotropic compounds. Now next is hydrocarbon refrigerants. Again, these primary refrigerants are classified into the second group, that is called as what? Hydrocarbon refrigerants. So as name indicates, hydrocarbon means what? These refrigerants contain hydrogens and carbons. That means these refrigerants have desired thermodynamic properties. These thermodynamic properties of these refrigerants are desirable, but these refrigerants are highly inflammable. If the refrigerant is leaked from the system, there is a chances of fire. Due to this, again, the use of these refrigerants is limited. For example, methane, ethane, propane, butane. So these are the hydrocarbon refrigerants. Now the next is inorganic compound refrigerants. So these refrigerants were universally used for all the processes before the introduction of halocarbon group. In the initial stages, these inorganic compound refrigerants are mainly used. The designation of these refrigerants is given according to their molecular weight added to 700. For example, suppose ammonia. Ammonia is the inorganic compound. If you want to give the designation to this ammonia, so the molecular weight of ammonia is 17. If we add this 17 into 700, so the designation is R717, which is mostly used in ice plants, cold storage, or in case of food refrigeration systems. Similarly, water have the molecular weight is 18. So if we add this 18 into 700, so the designation is R718. Like carbon dioxide, air, sulfur dioxide. So these are the inorganic refrigerants. Now next is saturated organic compound refrigerants. So these are the hydrocarbons with ethylene and propylene base, and these are designated by printing the digit 1 before M minus 1. So what is M minus 1? We will discuss later. So this is about the classification of these refrigerants, mainly classified into two types, primary and secondary. Again in primary, four compounds are there or four types are there, mainly halocarbons, hydrocarbons, azeotrophs, inorganic compounds.